Welcome back, students. So this is our geometry instruction for distance learning in the spring of 2020. So what I want to do before we finish off the year is talk a little bit about circles, chapter 9 in our geometry curriculum. So two essential concepts for this week is given the diameter of a circle, this is the geometry concept. What happens is if you create a circle and then you identify two endpoints of a particular diameter, then if you have any other point on the circle and connect those 3 points, you're going to make a right triangle. So we'll focus on that real fast, looking at something that I created on GeoGebra. So kind of a neat math app that I experiment on. So what I did for this was, let's see. There we go. So what I started with was a location for A and then a location for B. And I connected those, found the midpoint. All right, so that makes AB a diameter. Now, after that, I constructed a circle centered at the midpoint, which I labeled O, with a radius from O to A. And then what I did was I picked a point on the circle that was created. All right, point C. Now, I let the GeoGebra app measure the angle from A to C to B. Okay, so anywhere that I move C, it's stuck on that circle. So anywhere I move C, notice that the angle remains 90 degrees. Yep, no matter what I do. Okay, so that's basically what that concept is. So you're given a diameter of the circle, which is AB. Okay, so the two endpoints of the diameter are A and B. And then if I choose any other point on that circle created, okay, by that diameter, right, it's going to guarantee that I get a right triangle. Now, geometrically, that is going to come into play. We'll go through the algebra behind it. But as far as geometry goes, when I give you this assignment, what's going to happen is there's going to be two ways to find a third missing point on a right triangle. Okay, so what we're going to see when we get to that problem is there's an algebraic way of finding a missing point, and then there's a geometric way of finding a missing point. Okay, so we're going to end up working both of those. All right, so as we jump ahead to question number 10, what I did on GeoGebra, because it's a geometry technique, is I plotted point A and I plotted point B, sort of like we did here. You know, you had A and B were the endpoints of a diameter. Okay, what I did was I plotted point A. I've got the points mixed up. Let me just relabel those. Let's see. Real fast. Let me just relabel those. That one should be B. That one should be C for this problem. Okay. So basically what I'm going to do now is the same concept as what I spoke of without the graph. All right, given points A and B, that's the diameter, right? I can find the exact midpoint, create a circle, and then anywhere on that circle, okay, anywhere on that circle, it's going to allow me to create a right triangle. As long as I stay on that circle, okay, that point C is going to be helping me create a right triangle. So now how do I apply it to question number 10 over here? Okay, I want to find that point C that'll make it a right triangle with a right angle at C. Now, it's a little tricky. It'd be easy to choose this point right here, that would make, that's one location that would make a right triangle. Well, why then am I up here? Why not just go straight to this location right there? Well, that's because in the problem, they told us that the x value was 2. Okay, so for this particular problem, they're going to make it a little more challenging. Of course, one location that would make it a right triangle would be over at -4, -9. Okay, that would make it a right triangle. Or at 6, what is that location? Looks like 6, 1. Okay, those would be easy ones. But our restriction on this problem is that we have to have an x coordinate of 2. Okay, so one way to do it is, of course, algebraically, which we'll get to in a minute. Or we can kind of use that same system, right? Find the midpoint, construct a circle with our compass tool, and then you'll find that location C. Well, that's what I've done here. Basically, I've let this GeoGebra app, after I've plotted A and B, I found the midpoint. In this case, it's D. I let GeoGebra plot a circle, and at X is 2, it looks like Y is going to be 3. That's going to create a right angle. Now, I'll just prove that to you if I connect them. Okay, it looks like it's going to be a right triangle. We can prove that using slopes, by the way. That would be another geometry system. Or we can just verify here. We'll measure the angle. I'm sure it's going to be 90 degrees. And it is. Okay, so that's going to be, for this topic, that's going to be Roman numeral 1. Given the diameter of a circle, okay, the 2 endpoints of the diameter will create a right triangle with any other point on the circle. Thanks so much.